This is section 5.4 notes, day 1 and part 2. In example number 3, we're going to be graphing y equals tangent of 2x. So first of all, we have a k value here. Our k value, our k value is 2, and of course that's going to change our period. Remember, our period is pi over k, so in this case, our period is going to be pi over 2. So what is this going to do to our graph? It's going to smush it horizontally. It's going to be a horizontal smush because the period is accelerated, right? The period is happening in a quicker distance than it normally would. All right, now something that you need to think about, when you change the period, both the left and right sides of your asymptotes either move in or move out. In this case, they're going to be moving in. So you may want to make that note for yourself here. When you change the period, both left and right sides move in or out. Okay. Both left and right sides move in or out. All right, so normally our period is going to be pi, right? And our asymptotes are typically at negative pi over 2 and positive pi over 2 for tangent. So what that's going to do now, if our period is just going to be pi over 2, then that's going to change our asymptotes. So the first thing I'm going to do is a little labeling here on my axis. Here's 0. This is going to be negative pi over 4, negative pi over 2. This is going to be positive pi over 4, positive pi over 2, 3 pi over 4, pi. So my asymptotes are normally at negative pi over 2 and positive pi over 2, but because our period is going to be half as long, now our asymptotes are going to be at negative pi over 4 and positive pi over 4. And then we can go ahead and sketch as many asymptotes as we want, because each time we draw the graph between the asymptotes, we're sketching one period of our graph. Nothing else is really changing here. The shape of our graph is going to remain the same. So we're still going to have that point in the center of each period. And our graph is still going to go up from left to right. The shape of tangent isn't changing. So if this is negative 1 and this is positive 1 on our y-axis, our points are just going to be halfway there between the center and the asymptote. It's just going to look like that. Basically, it's the same exact shape. It's just smooshed into half the width. So things to consider before you're graphing tangent, and I'm going to actually cross this out because we're not going to be graphing cotangent here. Our parent asymptotes are always at negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, etc., etc. And our parent x-intercepts are at 0, pi, 2 pi, 3 pi, right? Those are always right in the center of our periods. The new asymptotes are half of the parent asymptotes. This is for the graph that we just made. Our new asymptotes are half of our parent asymptotes. So that's where we got that negative pi over 4, positive pi over 4, 3 pi over 4, 5 pi over 4, etc., etc. And our new x-intercepts are half of our parent x-intercepts. So that's how we got 0, pi over 2, pi, 3 pi over 2, etc., etc., etc. Okay, so all of this information here is for this graph because we changed our period with a k value of 2. So really you should just think about where things are moving before you make your graph. Our last example, we don't have a change in period, but we do have a phase shift. So our period for this graph is still going to be pi, our normal parent period, but we have a phase shift of positive pi over 3, which is going to be to the right. Okay. So what we want to think about here, and I'm going to kind of fill in the information on the bottom as I graph on the top. One asymptote of our parent graph is at negative pi over 2. But if we're shifting everything pi over 3 to the right, then our next asymptote is going to be pi units away because of our period. So what I'm going to do here, I'm going to label my x-axis, pi units away because of the period. Right? Every period takes place within pi. And the x-intercepts are going to be the points in the center of my asymptotes. Okay, so I'm going to do a little bit of labeling here, and then we'll talk about where things should go. Since I have a phase shift of pi over 3, I'm going to count by pi over 3 instead of by pi over 4 or pi over 2, just because that makes a little bit more sense. So I've got 0. This is going to be positive pi over 3 and 2 pi over 3 and 3 pi over 3, which is pi. And then this is going to be negative pi over 3, negative 2 pi over 3, and negative pi. Okay. So our original asymptote is at negative pi over 2, right? And our new asymptote is going to be shifted pi over 3 units to the right. Okay, well remember that negative pi over 2 is the same as negative 3 pi over 6. So if we're at negative 3 pi over 6 and we're shifting pi over 3 to the right, then we're going to be at negative 2 pi over 6. Well, 2 pi over 6 is exactly halfway between, negative 2 pi over 6 is exactly halfway between 0 and negative pi over 3. That is a little bit tricky to figure out. You really have to think about fractions there, okay? So that's where our first asymptote is going to be. And then our next asymptote, we have to shift that one as well. So that's going to be halfway between 2 pi over 3 and pi. Because remember now, we're counting by pi over 3s. So a unit of pi would be 3 squares y, because we're counting by pi over 3s. We have to consider our phase shift and our period. This is a very complicated example. So then our next asymptote, if we count 3 units over, would be right here. Okay, once you figure out the first one, you can kind of take it from there. All right, we know, and now the rest is pretty easy. We know that tangent is going to be at 0 right in the center of our period. So we have to have an x-intercept right there and an x-intercept right there. Okay, then we know that our graph is going to be up at positive 1, halfway between the center and the asymptote. So that is going to be right there, about 3/4 of the way. 1 and 3/4, 1 and 3/4, 1 and 3/4 units, I guess. So right there and right there. Again, I'm not worried about, I could figure out exactly what those values are, but it's not important. It's just important to figure out exactly where they go. Right here and right here. I'm just dividing that distance in half. There we go. And I just graphed 2 periods of y equals tangent of x minus pi over